Hello everyone, welcome to this video. In this video, we are going to learn addition rule for probability with the help of an example. Here is that example. The table below summarizes results from 985 pedestrian deaths that were caused by automobile accidents. If one of the pedestrian deaths is randomly selected, find the probability that the pedestrian was intoxicated or the driver was intoxicated. Here is the table. Here we have driver intoxicated or not. So if we check that, the driver can be intoxicated, yes, or the driver is not intoxicated, that is no. Similarly here, pedestrian intoxicated, yes, the pedestrian was intoxicated, or no, that is the pedestrian involved was not intoxicated. So here we have a total of 985 accidents. So 43 plus 77 plus 218 plus 647, that will be 985. For example, to understand the meaning, for example, if we take this 77, that means 77 accidents were caused because the driver was intoxicated, yes, and the pedestrian was not intoxicated. So that is the meaning of that. Similarly, if we try to read this number, say for example 218, 218 accidents were caused when the driver was not intoxicated, no, you can see here, and the pedestrian involved was intoxicated because there is a yes. So that is the meaning of that. Now let's try to quickly add these numbers. 43 plus 218, if we add that, that is 261. Meaning of that is there are 261 accidents where the pedestrian involved were intoxicated. Yes, the pedestrian was intoxicated. Similarly, here 77 plus 647 is 724. Meaning of that is there are 724 accidents where the pedestrian involved was not intoxicated. No. Now, if we add 43 and 77, 43 plus 77 is 120. And that number represents the total number of accidents where the driver was intoxicated. 120 cases where the driver was intoxicated. Similarly, if we add 218 and 647, it will be 865. So 865 accidents were there where the driver was not intoxicated. So that is the meaning of this contingency table that is given here. Now we are asked to, let's see, what is the question? We are asked to find the probability that the pedestrian was intoxicated or the driver was intoxicated. So the question is, we have to find the probability that the pedestrian was intoxicated. Let me write PI, pedestrian intoxicated, or or the driver was intoxicated. Driver intoxicated. So because we have or, this is the addition rule for probability. And if we look at this table, there is an incident where both pedestrian and driver are intoxicated. For example, this 43, these are the cases where, or accidents, where the driver was intoxicated and also pedestrian was intoxicated. So meaning of that is the events where the pedestrian was intoxicated and the driver was intoxicated, that is mutually inclusive event. So if we use the addition rule, it will be probability that the pedestrian is intoxicated plus probability that the driver was intoxicated minus the probability that the pedestrian was intoxicated and the driver was intoxicated. We use this formula because the events are mutually inclusive, or They are joint events. Now, probability that the pedestrian are intoxicated. So we have a total of 261 accidents where the pedestrians were intoxicated. So the probability will be 261 out of 985. 261 out of 985 plus probability that the driver was intoxicated. There are 120 cases where the driver was intoxicated. So it will be 120 out of 985. And then we have a minus probability that the pedestrian involved was intoxicated and driver was intoxicated. So that is 43. There are 43 accidents where the pedestrian involved was intoxicated and also the driver was intoxicated. So that is 43 out of 985. That is equal to, now we have a same denominator. So 261 plus 120 minus 43 is 338. 338 over 985. So if we change that to decimal, it is 0.3431. 0.3431. So that is the probability that the pedestrian was intoxicated or the driver was intoxicated. So what we have done in this example is we look at the events. We saw that the question involves or, so it is the addition rule. And we also saw that the events are mutually inclusive. So we use the formula for mutually inclusive events. We use the addition rule of probability, and then we use the proper values to find the individual proper probabilities, and we simplify that to get this probability. So this is the probability that the pedestrian involved was intoxicated or the driver was intoxicated. I hope you find this video helpful. Thank you so much for watching.